All right, so let's extend the chain rule just a little bit. More chain rule. So let's take, let's not call it f of x, let's call it y equals the cosine of 3x plus 7 all to the 4th power. So now what I have here is a composition of 4 different functions. This is an f of g of h of x. So I have 4 functions nested together, and it turns out you can apply the chain rule to that. And what ends up happening is you just get these, you keep chaining stuff literally along. So if you were to take the derivative of something like this, and I'll spend more time on this next class, you're going to get the derivative of f times the derivative of g times the derivative of h. Now, the chain rule says that you leave the innards alone. So what was inside of f? Well, inside of f was g of h of x. So that's still stuck in there. But I take the derivative of whatever I decide the function f is. G, when I take its derivative, I leave its innards alone, which is just h of x, and then we have x there. And this works for 3, 4, a composition of as many functions as you ever wanted. So in order to make this happen, I have to be able to look at a function and decide what's the outer function, what's the inner function, and in this case, I also have a middle function. Right? So if we look at this one right here, I need you guys to help me out. In that sequence of events up here, what is the outermost function? What is the middle function? And what is the innermost function? So anybody want to take a stab? Identify at least one of those for me? Okay, so Kelsey says the outer is the 4th power. That is correct. Outer is whatever to the 4th power. And Kelsey said her sister says that, oh, quote fun. Oh, come on, this is fun. All right, I'll take quote fun. The middle, yeah, is the cosine of whatever. And the inner would be the 3x plus 7. So then we take the derivatives. I'm just going to make a little arrow and put a little d for derivative there. The derivative of something to the 4th power is 4 times whatever to the 3rd power. And the derivative of the cosine is the negative sine of whatever was inside. And the derivative of 3x plus 7 is just 3. So then we put that all back together. So my y prime here is going to be, start with the outer function. So that would be 4 times whatever cubed. All right, and the whatever is whatever was inside that 4th power originally, so that would be the cosine of 3x plus 7. And then I multiply that by the next derivative, which is the derivative of the middle function. So that's, I'm going to put a parentheses because of the negative there, negative sine of whatever. Okay, what is the whatever inside the cosine? And the sine, well, that's whatever was inside it up there. So then I drop in my 3x plus 7. And then finally, I get to multiply by the derivative of the inner, which is just 3. And then we just try to clean that up if necessary. And it is necessary. So let's see, we've got a 4 times a negative 1 times a 3. So I'm going to get a negative 12. And then cosine cubed, I could just write as cosine cubed like that. 3x plus 7. And then I took the negative up front already, so then I just get the sine. It's a lousy S. Better. Sine of 3x plus 7. All right, did I get everything? Double check. So sometimes I like to mark off. I got the 4, I got the negative, I got the 3, I got the cosine cubed, and I've got the sine. And when I left the insides the way they were, yep, looks like I accounted for everything. Does that clean up? Not really. There is an identity, like there's identities for squares of trig functions, there's identities for cubes, but that turns it kind of into a product and a sum, which I don't think is going to make a sum would make this worse. So I'm leaning toward that is the simplest thing we're going to get. Most likely simplest. And the only way to really know is to start throwing some identities at it, doing some algebra, and see if you end up using less ink eventually. But we got to use a whole lot of ink to get there. So that's that. Oof, that was exciting, wasn't it? So the chain rule applies whenever we find ourselves with a composite function. So let's do one more. Let's suppose we have the function y equals the sine of 3x plus the cosine of 2x. And I want to find a tangent line when x equals pi over 6. So we need to know the slope function, which is y prime, or dy dx. And so taking the derivative of the sine here, its derivative is the cosine. The 3x stays put for a moment, and then the chain rule says if there's anything but an x in there, you have to multiply by its derivative, and so that would be times 3. So anytime we have a function that has something besides an x inside of it, we got to say, oh, chain rule, plus derivative of the cosine, so that would be the negative sine, leave the 2x alone, and then multiply by the derivative of 2x, which is 2. And there's not much we can do to clean that up, except maybe to write it as 3 cosine 3x minus 2 sine of 2x. And I could have used like the double angle formula here, and there is kind of a triple angle formula, but it's kind of a mess. So I don't think we get anywhere if we try to use some trig identity on this and then take the derivative. I think any trig identities would make this slightly more complicated. And there's also a sum to product rule, but then we'd have to use the product rule, which is more complicated than taking the derivative of a sum. So I think this is likely the simplest form of the derivative that we'll find, and now we just need the slope. So what is y prime of pi over 6? And a notation I haven't used yet with respect to like the dy dx, if you want to take the derivative and then plug in a number when you're using this form here, you draw a vertical bar, and then at the bottom of the vertical bar, you say what x value you want to plug in. So you might see that notation in the homework of the book. So that just means take your derivative and plug in the number you were given. So cosine of 3 times pi over 6 minus 2 sine of 2 pi over 6. And 3 over 6 is really 1/2, so that's 3 cosine of pi over 2 minus 2 sine. 2 over 6 is 3, so that would be pi over 3. And just thinking about the unit circle for a second to evaluate these guys, pi over 2 is 90 degrees up there. Cosine is an x value, so this right here is 0. Minus 2 times sine of pi over 3, so that's pi over 2 up here. Pi over 3 would be this angle right here versus pi over 4 and pi over 6 there. And at pi over 3, the sine is square root of 3 over 2. And just remember the main numbers you need to know in that unit circle are like, this is the point 0, 1. And then for pi over 3 and pi over 6, you have the values 1/2 and square root of 3 over 2. So this one up here, pi over 3, x is 1/2, y is square root of 3 over 2. And when I look at the picture, right, I can see if I trace that down, that looks like about 1/2 right there. And pi over 6 switches it. If we trace over this way, you can see, yeah, that looks like about 1/2 right there. So this would be the point at pi over 6. Pictures of us out of the way. Sorry, I missed on my screen. And this point right here would be square root of 3 over 2, 1/2. And then at pi over 4 in the middle, hopefully you remember that's the point, square root of 2 over 2, square root of 2 over 2. So I do hope you remember that from trig, because it makes these, you can get exact answers here. So I'm getting an exact slope of, looks like square root of 3. Then the point slope formula, y minus y1 equals m times x minus x1. Let's see, oh, I have not calculated the y value here. So let's do that too. Let's squeeze it off to the side here. If I take my y and evaluate it at pi over 6, I get, so that's up here, sine of 3 times pi over 6 plus cosine of 2 times pi over 6. And then 3 over 6, so that's sine of pi over 2. And this would be cosine of pi over 3. Let me clean that up. Let's see, sine at pi over 2, that's the y value, that's 1. And then the cosine at pi over 3 is x value, that's 1/2. So it looks like this is 1.5, 1.5, or 3/2, however you want to write it. I think I'll stick with fractions here. All right, so my tangent line should be y minus 3/2 equals the square root of 3 times x minus pi over 6. And solving for y is as simple as just adding the 3/2 to the other side. So I could say it's square root of 3 times x minus pi over 6 in parentheses plus 3/2. And my watch says I should shut up now. 3/2. So I just ran out of time for fun with math. It's 9:50. But the next thing I would do is to graph this right here, find the point pi over 6, 3/2, and see if this is really the tangent line. Did I actually find it? All right, so we are going to continue to play with the chain rule next class to get used to identifying the outer and inner function, or every once in a while it's even more complicated, like we have an outer and inner and a middle, and it just takes practice. So please jump on the homework right away, do some homework today, do some more homework over the weekend. On Monday, we're going to do more chain rule before we move on to the next section. And we have a few more sections to cover before we're done with this chapter and ready for the next test. So take care, do good math. I'll see you in the near future. Bye-bye.